Good. Okay. Is it recording? Perfect. So do you have any specific, general questions about the exam? The exam will be 12, minimum of 12 questions. It might be 15, could even be 16 or 18. That depends on how long your teacher has given for the exam. So a lot of you will be taking the exam in the testing center with the 2-hour window. You have a little more time. The nice thing about having more questions is if you don't understand one question, it doesn't drop your grade as much when you have other questions to bring up your grade. There are 3 modules out of 5, and the one that you're sure going to see is the measurement and problem solving. Now, I'm not going to cover the algebra review, the prepare for measurement. If you're in a Math 1035 course, I'm not going to cover those in the review because those are things that are not going to be on the exam specific. You just need to know the actual like measurement problem solving module or the trig or the etc. So the first 5 are potential, 3 of those 5. Okay, can I get an idea of how many people have their course covering the trigonometry? You can do a little thumbs up or equivalent on your screen. No one has trig? Does anybody have the graph theory? No for graph theory? Okay, so you all have the measurements, the set and logic, and the voting theory. Okay, that will make this even better. Open up a chat. I will be checking the chat as well. I have a dual monitor set up for this, so if you have questions, please put them there. Let's see, there should be. Oh, I can send files. So what I'm sending you now are 3 different PDFs. If you're in my class, you should already have these available. There's the measurement problem solving. And set theory. And voting theory. So my thought for the review, here you see it, an example. So the measurement and problem solving, on the left side, the work is already done in these notes, and the right side is blank. And these videos show the work on the left side. So any time you see this little icon, you'll see the work that's done. You'll see me explain it instead. It'll be blank and I'll go through it. So for the review, I was thinking we could cover the right side, as well as any questions that you have from any of the homework. So the homework is the ultimate way to review for your exam, because I've written the exam templates and I basically looked over the homework and quizzes to get the content that I put on the exam. And then I let faculty choose which of those questions they put on the exam. So you have the architect of all the exams. So if you don't like your exam, you can partially blame me for putting those questions available, but you can also blame your teacher for choosing those questions. But ultimately, at the end of the day, you just got to stare in the mirror and realize that you could have done more and we could have done more. And, you know, we all get to do that every night. Okay, so starting off, the unit conversions will be given. There are some things that are not on these notes that are on the homework. For example, borrowing and carrying, like adding feet and inches together or subtracting feet and inches together on the borrow carrying process. So if we have time, we can cover those as well. But essentially, when we are converting, you're trying to convert from one thing to another. I always take the thing that I'm trying to convert, like 2 pounds, and put it over 1, and then multiply by a conversion factor. Now, what's important is my conversion factor in the denominator has to have pounds so that I can reduce those units. And this information will be on the exam. You won't have to know all of this, but pounds to ounces, weight, there we go. 1 pound is 16 ounces. So this is the conversion that we need. So we have 1 pound and 16 ounces. So the units of pounds reduce, leaving us the units of ounces. Now this 16 ounces over 1 pound, since they're equal values, this is actually a form of 1. And multiplying by 1 doesn't change the value of what you started with. In this case, a weight, it'll still weigh the same. 2 times 16 is 32 ounces. So pretty straightforward. Figure out what you're trying to convert and what you're trying to get to. Start with what you're given. Put it over 1 if it's not a rate. If it is a rate, it'll already be a fraction. And then make sure the next unit has the correct conversion set up, so that in this case the feet on top and the feet on bottom. And 1 foot is, let's see, we want to go to yards. 3 feet is 1 yard. In this problem, we get the feet to reduce, and we have 48 times 1 is 48, divided by 1 times 3 is 3. 48 divided by 3. And that is, now here's a plug for, make sure you have your calculator for the exam, and that it's not a brand new calculator, that you're very comfortable with it and you know how to use it easily. You want it to be your friend, you don't want it fighting you. Now, for these story problems, make sure to write the units. If you don't write the units, your teacher should be taking a point off, at least. Each question is worth 6 points. It shouldn't be a lot of points off for not using your units, but this is part of these story problems, is having a story answer. So if we wanted to convert 1 year into seconds, we start with 1 year. We can put it over 1. And then we have to get 2 seconds. I know that in 1 year, there are 12 months. Let's go to days. That's probably safer. 365 days. And then in 1 day, there are 24 hours. And in 1 hour, there's 60 minutes. And in 1 minute, there are 60 seconds. The most important part of this is keeping track of that your units are going to reduce. 1 on top, 1 on bottom, 1 on top, 1 on bottom. And in this way, multiplying by a series of 1, you change your units. And then, even if the stuff is something you could do in your head, I wouldn't do any math in my head on an exam day. It says 2 times 3, I'm doing it on my calculator. I am not doing 2 times 3 is 5 because I'm stressed. I see it grading. I know that happens. You don't want that. So do everything on your calculator, even if it's silly, even if you'd be embarrassed if someone looked over your shoulder and saw you do it. I don't care. No one's looking over your shoulder, or if they are, they're the testing center officials, and they're going to be proud, not like make you embarrassed. All right, so we work all that out. We get some big number. I'll pull that off screen so I can write it down. 3153600, and this would be seconds. So 1 year is 31 million seconds-ish. Don't round unless requested. It's another thing about mathematics in general. Don't do any rounding unless requested. And if requested, only round the very last step. Okay, so if we have a rate for kmph, kilometers per hour, this would be 4 kilometers, and the per is in the division, and 1 hour. So in this problem, we already have units in the numerator and denominator. We want to go to meters per second. We can choose, for example, let me do in red, the conversion from time, hours to seconds. So I know in 1 hour, there's 60 minutes. And in 1 minute, so now minutes is in the denominator. To convert out of there, I need a minute in the numerator. 1 minute, 60 seconds. And in that way, I have converted the time. Currently, my rate is kilometers per second. Now for the meters, kilometers is in the numerator, so I need a kilometers in the denominator. And 1 kilometer is 1,000 meters. And now my units, meters per second. I just need to work out the calculations. Now, all of these conversions that I've done, let's double check. There's the meters and kilometers. The time, 60 minutes in an hour, that stuff you should know. And that's universal, so we assume that you do know that. We won't give you time conversion factors. Okay, on your calculator, when you're going through this, if there's a number in the denominator, make sure it's preceded by a division sign. So this is 4. You don't need the 1, so don't do a divide by 1 if not necessary. You don't need the times by 1. So this next one would be a divide and then a 60. The next one is another 60 in the denominator, so another divide sign and 60. And then the 1,000 is in the numerator, a times sign. Now this decimal goes on forever, but they do ask us to round to the nearest 100. Now the 100th is the second one. We look to the right of that, and that 1 does not round it up, so we would just have 1.11. Approximately 1.11 meters per second. Okay. So if you have a question and you don't want to speak up, just go ahead and put it in the chat.
So can you tell me how is it that you know when you're dividing versus timesing? Like you divided the 260s, but times the 1,000.
So if the number is in the denominator, it needs to be a division. If the number is in the numerator, it's a multiplication. So on this, so on this problem below, we'd start with a 1.2, then it would be divide by 60, then it would be divide by 60, then it would be times 33, and then times 5280. Yep. And sometimes the fraction will have a number on the top and on the bottom. Just do the times the top one and then a divide the bottom one. All right, next up in measurement. Ratios, percents, and proportions. So first off, the ratios. Ratios are simple fractions created by specific wording in problems. Typically, it's the ratio of x to y. And then we translate that into a fraction, x over y. So on question number 11, an employee pays $475 towards health insurance, while the employer pays $500. Simplify the ratio. So here we have the ratio of the employer to the employee. So the first part, the employer, that goes on top. To the goes on the bottom, the employee, and that is employee 475. Now, when you create a ratio, typically the units will reduce, which we see here. But we also need to reduce the fraction. Here's where it's nice to have tools that you are familiar with. If you had to, you could just do the whole division and it'll get some decimal. And if you know your tools well enough, you can have it convert to a fraction for you. If you don't know your calculator that well, I would do a quick Google search for like converting from fractions to decimals or something like that. That's not the only way to do this problem though. So 20 over 19. Good. The other thing would be, I can see that there's a 25 involved in both of them. So I would divide the top by 25 and divide the bottom by 25. If I do the same thing in the numerator and denominator, the multiplication or division, that's actually a form of 1. I'm multiplying by 1. And therefore I won't change the value. And then 500 divided by 25, there's 20, that's the numerator. And 475 divided by 25 is a 9. Oh, I did 475. I didn't do 475. There we go. 20 over 19. That is the simplified ratio. So the way to create the ratio depends on what thing goes before the word 2 and what thing goes after. The stuff before is in the numerator. The stuff after the word 2 in the ratio is in the denominator. So number 12, out of 330 ratios, ratio, there's the word 2. So we need the numerator is the stuff before, and the denominator is the stuff after the word 2. So disqualified racers, 12, over total racers, 330. And then we reduce this. Let's see. First off, can I reduce the entire 12 out of the 330? No. I can reduce a 6 though. There we go. So if I divide the top and bottom by 6, I get 55 to 2 over 55. And again, if you know your tools, your calculator well, you can get that answer by letting it do the work for you. A lot of you have a fraction button around here on your calculator. And there might be an F arrow D button that goes from fraction to decimal back and forth. And some of you have a button down here that like an arrow left, arrow right button that converts from math print to decimal form. That could also be the button that works. All right, percents. The first one is the percent of the whole. And this is just percent is divide by 100 and of is times. So Dallas wants to determine what percent of her trail mix is chocolate pieces. So she counts out exactly how many of each are in her bag. There are 16 raisins, 24 chocolate pieces, and 44 peanuts. What percent of pieces in the trail mix are chocolate? So percent of the whole is a ratio. It's how many partial over how many total. And in the total, we'd actually have to work out how many total there are by adding up all the individual items. So if I do the 16 plus the 24 plus the 44, we can determine that there are 84 different items in her bag. And percent of the whole is the partial over the total. I think I have that somewhere in here. Ratio of the partial to the whole. Okay, perfect. So we have 24 over 84. That's a ratio. If we convert this into a percent, we do this with a division and then multiply by 100. Round to the nearest whole percent. So this would be 28.57-ish would round up to 29%. So they want the nearest whole percent. Now, look at the number before, 0.2857. That's not a percent. If I said round to the whole, you'd round that to 0. So you want to make sure if they say round to a something percent, that you first write it as a percent and then do the rounding. So your rounding is your last step, 29%. Okay. So common rounding for percents is a whole percent or a tenth of a percent. Go to percent and then round to the whole or to the tenth. I don't know, 29% of that's chocolate. Anything less than 100% makes me worried. All right, next up. By the way, put in chat if you do not have access to the files that I sent out earlier in the class. That was at 10:04. I want to make sure that you have access to the file that I'm working with today. But just chat, need the file. And if someone else in class, hopefully you've downloaded those for yourself, you can chat it to everyone and share it back if you see someone needs it. All right, the sales tax rate, 7.05%. What is the state sales tax on this valued car? So we have a car and we need to pay sales tax. So again, this is a percent of problem. So we want to find 7.05% of the 28,800. I do this with a direct translation. Now I have a message in the chat. What is a good calculator to use or to get? I like the TI-30X2S. That's my preferred calculator. It's not the only one, obviously, the TI-30 type. But that's the one I like. It's cheap and like 12 bucks or something at Target or Walmart. And the layout of the keys are very similar to this calculator. This is a graphing calculator, but the layout's very similar. So you can watch this video and be able to do what I did easily. If you have a cell phone and that's what you use for your calculator, you're going to show up to the testing center. They're not going to allow you to use your cell phone. And then you're going to have to do all this by hand. So don't do that to yourself. Make sure you bring a calculator to the exam. They might have them to borrow, but I wouldn't count on it. All right, so back to number 16. Percent literally means divide by 100. So I don't move decimals in my head on test day. I let my calculator do it. Divide by 100. Of is times. This is now very safe. The 100's in the denominator, so divide, then times. $2,030.40. Now, when we're dealing with money, you do round to the nearest penny. So 2030.4. So you'd round it, you'd write it to the decimal hundredths spot. That's the sales tax on that car. Percent increase, percent decrease. So there's a two-step process and a one-step process. I don't know how your teacher taught it. I think the two-step process is very logical, just not as efficient as the one-step process. So I like to do the one-step process, and I have those in the notes. For an increase, you multiply by 1 plus the percent increase over 100. And for a decrease, 1 minus percent decrease over 100. So on number 18, a 30% off, this is a decrease. So we have $45, and then we multiply by this decrease. It's 1 minus the percent decrease, 30, over 100. $31.50. Now that method is so fast, it's like, do I have to memorize that? Really, what's going on? If I cut off 30% of the bill, I still need to pay 70% of the bill. If I have a 30% off coupon, I still have to pay 70%. And so this is really just what is left of the bill. And we can verify that. 1 minus 30 over 100 is 0.7. So this makes a very fast and efficient approach to the percent increase or percent decrease problems. Sales tax rate, 8.1%. This is a percent increase because it's a tax. So we have $301 before tax, and the percent increase is 1 plus the percent increase over 100. Now this would be 301 if we did this part inside, 1.081. In other words, we need to work out what is 108.1%. So we have to pay the original 100%, and we're adding 8.1% more. $325.38. How much this item will be after tax. The reason why I like the one-step process is on questions like number 22, we have a piece of art costs $130. You increase the cost by 80%. So that would be 1 plus 80 over 100. But your mother purchases it, so you give her a 30% family discount. That's a 1 minus 30 over 100. And you can do all the increase and decrease. And I mean, maybe there's tax as well. All of that can just be done basically in one multiplication in your calculator. You would charge her $163.80. So you can see on the left, and again, these icons right here, this is a video that shows you how I'm doing the left side. But this is a decrease because it's minus, decrease, increase. So we can see it's a 20% decrease, a 15% decrease, and then a 6.25% increase, all in one step, just to get the final answer. Very efficient. All right, absolute change and relative change. The absolute change, this book has the absolute value bar around them. So you always have a positive value for absolute change. which means it's up to you to explain whether that's an increase or a decrease using English. Other books do not have the absolute value around it. And I am actually thinking we should change this book because it's weird to have that. And I'm on the committee that can change this book, so I think we might do it. Okay. So the key is that it's the new value minus the old value for the absolute change. And then the new value minus the old value over the old value for the relative change. So on number 24, so the from is the old value, and then to is the new value. So we're going from something to something else, the original value to the new value. So the absolute change would be the absolute value, the old value minus the new value. 25, 18, 6, 25. And what I just did, do not do on the test. No math in your head, please. There we go. Now, notice it went from 24 to 17. I did this wrong, didn't I? I'm reversed. New value minus the original value. I have these exactly reversed. The absolute value is going to make it so it doesn't matter. You still get the same answer, but I had them reversed. Apologize for that. Old, new minus old. New minus old. So because this thing dropped, we have to say decrease. That's what we'd want to have for the absolute change. In absolute terms, it decreased $6.25. Now the relative change, you can either do the entire fraction, new minus old over old, or you can just do the absolute change over old, since we already did the top part. But you divide by the original value, and that dividing by the original value puts this into perspective. 0.26. And as a percent increase, percent decrease, let's multiply by 100. Again, I'm doing the multiply by 100 and divide by 100 because I don't want to mess around with my brain moving decimal places on the test. Just let your calculator do this work. 26.04%. But again, we have to use the English decrease because the absolute value wiped out whether it was an increase or a decrease. Okay. So when you divide by the original value, it puts it into perspective. If the original value had been 7 and we changed by 6.25, that's almost 100% change. That'd be a huge change. So you have to divide by the original value, then you get the percent increase or the relative change. Okay. Now, with the percent, the relative change, the absolute change, you can also compare two different objects, like in this case, SOCC awards and Utah State University awards for associate's degrees. So what we have to do, we have the first one as compared to the second one. So the being compared to, you can see on the left, the one being compared to is called the base of the comparison, takes the original value in our formulas. So as compared to SLCC, that's the base. That's going to be the original values. So Utah State goes first, and then SLCC. So this would be the absolute change. Negative. The absolute value wipes out the negative, but then we have to put in English, fewer. So we could then say Utah State has 1,905 fewer associate degrees awarded. And that makes sense from the numbers. The relative change. You divide by the comparison value, the base value, SLCC, and multiply that by 100. Oh, I already have that in there. Oh, I don't have that in there. $58.59, so 58.6. I don't know the rounding. It doesn't say what the rounding is. Now we can say that Utah State awards 58.6% fewer associate degrees than Salt Lake Community College. So we have the exact number and a percent as well. Now, if we change this around, now SLC as compared to Utah State, now Utah State takes the place of the original. The absolute change will be the same, but the numbers do switch. But this time it's a positive number inside, so we would say more. So now we can say SLCC awards 1,905 more associate's degrees than Utah State. Kind of an obvious thing because we just had the fewer, now we have the more. But the relative change is the weird one. It's not necessarily weird, but it's not what you expect. You divide by the original value, which is when you're comparing to, or the base value, Utah State. That was 1346. And multiply by 100. $141.53. Now we can say SLCC awards 141.53% more associate's degrees than Utah State. So the absolute change, when you flip the order of the numbers around, doesn't change, except for fewer versus more, but the relative change does. So 1346 is 58% fewer than 3251, but 3251 is 141% more than 1346. It depends on which one is the base value, which one you're comparing to. All right, proportions. Two ratios that are equivalent. In order for two ratios to be equivalent, the rates need to be the same. So there are 230 calories in a 48-gram packet of M&Ms. Assuming M&Ms are all the same basic amount of calories, then they have the same rate of calories per gram of M&Ms. We can use that fact to get how many calories in a different sized bag. So the question here is how many calories. So if I'd let that be X, I would want to solve for that. So I would have that on top. X calories are in 9.6 grams So we now have calories on top, grams on bottom. We go to the previous full complete statement, which is 230 calories in 48 grams. To solve for X, all we need to do is multiply by the 9.6 grams. Both sides, you have to multiply both sides of an equation to keep it in balance. And we have X calories equal. On the right side, the grams reduce. And so we'll get calories, which is what we want. And then it's just a matter of multiply the 9.6, it's on top, and divide by the 48 because it's on bottom, 46. Simple ratio, equivalent ratio, so a simple proportion. How many cups of sugar? All right, so I'm going to let it be X cups of sugar. Will you need to make 8 cookies? So we've established the form of the ratio, cups of sugar on top, 8 cookies on bottom. Now, again, we're assuming that if we double the recipe, it's going to be the same ratio of sugar, the same rate of sugar. If all of a sudden we went from one type of sugar to another type, then we couldn't use this conversion factor because they might have a different proportion of sugar, like in oatmeal versus a sugar cookie. But this, we're assuming it's the same cookie, same recipe. You need 1 1/4 cups. So I'm going to go with 1.25 for 20 cookies. But if you know your tools, you can do a 1 1/4. There's a fraction, a mixed number button, and everything else. All right, so again, to solve for X, we just need to multiply by the denominator, 8 cookies, both sides. Cookies reduce, the 8 reduces. Just calculate 1.25 times 8 divided by 20. We need 0.5, which I don't know if you know offhand, but that's 1/2. We want to express as a fraction or a whole number. We got a fraction. We need 1/2 cup of sugar. Okay, area and volume rates, sorry. You read online that a 15-foot by 20-foot brick patio would cost about $2,275 to have professionally installed. If we assume that they charge the same rate per area, then we can estimate the cost of having a different sized patio installed. But first, we need to work out what the actual rate would be. So the area of the original one, the advertised one, would be 300 square feet. So we could create a conversion factor. It costs $2,275 for 300 square feet. This conversion factor converts area to money. If they will charge the same rate, then we can work out our area of our new patio, 25 by 26. Was that 1,300 or something? I don't know. Forget, don't do that stuff in my head on test day. 650 square feet. I should actually have the units in here. Oh, let me do it this way. Feet and square feet. Feet, square feet. Nice. We can now take 650 square feet, put it over 1, and use this conversion factor that converts from square feet into money. And this will give us an approximation. Maybe they have special machinery that works in perfect 5-foot increments. And so a 15 by 20 is easy and a 25 is great, but the 26 will slow them down. So they might charge a little more. I don't know. There are some things that could come up, but we can at least estimate 49, 29, 17. If they went at the same rate, we can now go and ask them for a bid. And if it's somewhere around there, that feels good. If it's way more, there's something weird. If it's way less, take the bid. Hopefully they don't do a crap job that you have to do again. A rectangular aquarium. This is length, width, height. This is volume. So we find the volume. This will be cubic inches. What's the volume of this aquarium? I did a division. That's not good. Times 1404. So that's the size of the aquarium. And we know the hose that we're using takes 3 minutes. So we have a conversion from cubic inches to minutes. Now we can find the volume of this other size aquarium, and we can now assume the rate's the same because it's the same hose. So it'll be the same rate. So we work out the size of the larger aquarium, and this will be the volume. And then we can use our conversion factor that converts from volume to time. So there's a much larger one. Whoa. 35904. So that volume we could do, let's see, cubic inches on top. So we need our conversion here. We need to do the reciprocal. We need cubic inches on bottom to use it. $76.72 minutes. Approximately. All right. This section never ends. Problem solving. Have some formulas. Length, width, height, volume. We've used some of these. The circumference and radius area of a circle, cylinder. There's a figure made of a square inscribed in a circle. We want to know the area of the shaded region. So the shaded region would be the circle minus the square, or circle minus square would be this shaded region. So we just need to find the area of the circle, subtract the area of the square. This radius of the circle is 9.9 kilometers. So that would be area is pi r squared. And the area of the square would be length times width, which would be 14 kilometers times 14 kilometers. This is just basically a calculator problem now. You should have a pi button on your calculator, so make sure to use that. And 14 times 14 is just 14 squared. 111 point, rounded there's 10th, 111.9. And this would be square kilometers. How many cubic inches in a cubic yard? Now, this is very useful. You know, hopefully you know that one, let's see, so if we take off the cubic first and just think inches and yards, 1 yard, I have a cubic yard. Let me show you how to do it. We have a cubic yard, and we want to know how many cubic inches. So we're trying to convert from cubic yard to cubic inches. And I know 1 yard is 3 feet, but I can't use that conversion factor because the yard cube doesn't reduce with just a yard. But that's a form of 1. I can cube it. And now it'll work. In 1 foot, there are 12 inches. But we have a cubic foot, so we cube that as well. And this yard cubed actually reduces with this yard cubed. This foot cubed reduces with this foot cubed. And we end up with inches cubed. So this is true. Like right here, we actually have 27 cubic feet is 1 cubic yard, and 12 cubed inches in 1 cubic foot. But we don't need to know those conversion factors. And furthermore, they're not given. We just use the basic one and cube it if it's volume, or square it if it's area. And then our calculator makes quick work of it. 1 times parenthesis 3 divided by 1 cubed times parenthesis 12 divided by 1. I didn't need the divide by ones, but typing it in. There it is. 46656 cubic inches. Okay. I don't know where that was saved. Now, I don't know about you, but I think the voting theory is probably the easiest. And set theory and logic and measurement, I spent most of the time in measurement because I know that causes students a lot of troubles. But the set theory and logic, I really want to point out that it's not as hard as people make it. So I'm jumping to set theory logic now. In set theory, this is the union. And the unions like E and F both contribute everything they have to the union. So E contributes task, and F contributes B. A is already done, T is already done, and also H. You don't double list something. So it's a union. It's a combination of everything. Now, this is the intersection. Only stuff that's in D that's also in F will balance on that shape, like a teeter-totter. It has to be on both sides. If it's only in D, then this teeter-totter is going to fall off. If it's only in F, it's going to fall off. We want it to be balanced on the top of that shape. Oops, where's my eraser? There we go. So it needs to be both in D and F. So we look in D and F, and we see A, B and A are in both D and F. So this is both. This is either or. Both. Either one or the other or both. All right, now this notation, DC, is outside of. This is the universe, this is the complement. So what's outside of D and outside of F? So it's useful to create, and you're usually given the universal set. That's everything in all of them. It's the union of everything. I think that's it. A, B, C, H, T, S, K. Yep, that's everything. So what's outside of D? D is B-A-C-K, so the T-H-S is outside. T-S-H. And what's outside of F? F is bath, B-A-T-H. The C-K-S, that's outside of F. And then we want to know what's in both of those. S. That's the only thing that's outside of D and F, the letter S. Now that superscript C could also be written like this. That's another form. Okay, the intersection is what's in both. If you need to create this yourself, that's the universal set. There's A and B, make sure there's an overlap. What's outside of A and in B? Outside of A and in B, all of that. The only stuff that's not covered is actually this stuff. This is a union. Everything outside of A gets put in, and everything in B gets put in, including the stuff that was inside of A. Because B contributed it, it's in the union. $10.59, okay. WUT, so union or intersect F. So this is W, this is Wednesday, Thursday, Friday. You know, that's what I meant when I did WTF, right? I hope. I love writing notes and making stuff up. All right, so this piece is, it has to be in F. So the stuff that's in F includes this, 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 this. So the right side says it has to be in F. And so now that's what we start with. This says it's outside of what's in W and T. So because we're outside W and T, none of this stuff works. So now we're looking at what's inside of F and outside of both W or T. That's our final answer. Okay, this is mostly to understand the union, the intersection, and the complement, what those mean. If you need to fill out a Venn diagram to answer a question, like how many people don't use any alternate transportation, it should be what percent? Because we don't actually know how many people are involved. This is all percent. But let's say this is bike, this is walk, and then we also have bus. The one that use all three, we start with. We start from the inside out. 2% use all three. Then we move backwards. 12% use the bus and walk. So the bus and walk is this stuff right here. 12%. Well, 2% is already there, so the other 10% is in there. And there's our 12%. Do bus or walk. Oh, and bus and walk. 10% ride a bike and walk. Now, bike and walk is this stuff. 10%. We have 2 already, so the 8's up there. 8 and 2 makes 10% do bike and walk. And 5% do bus and bike. That's this stuff. 2 plus 3 is 5. And we work back. 25% walk. 25% are in this walk circle. We already have 10 and 10, 20%. So the other 5% is here. Those 4 numbers add up to the 25. 20% ride a bike. That's 13 already. So the other 7 is here. 7 plus 13 is 20. And 30% use the bus. That's 10. 15% are already, so the other 15% are. Great. Now this is where I would definitely go to the calculator. If I subtract each thing I see, so the 7, the 8, the 5, next row, the 3, the 2, the 10, and finally the bottom, the 15. There's still 50% of the people that are not in here. Because the universal set's 100%. What percent of people only ride the bus? 5%. How many people don't use any alternate transportation? 50%. So when you're creating these Venn diagrams, 2 and 3 Venn diagrams, start in the middle and like the last statement and work your way backwards until you have everything filled out. All right, logic. I think the most important thing to do is to go over these truth tables, because this really causes students a lot of trouble. Now we have this tilde symbol. This means the opposite. So if A is true, the opposite of A is false. If A is false, the opposite of A is true. There's an opposite there. That just means the opposite. Take whatever the stuff inside is and switch it. Now the upside down V and the right side up V are very similar to the set notation, intersection and union. So this is the intersection, this is and this is the union, this is or. So for A and B to be true, they both have to be true. If there's at least one false, then the whole situation, A and B, is false. So the A and B almost always is false. The only time it's not false is if you have a true. The A or B, as long as there's one true, the final value is true. If they're both false, then you get a false. So the A or B is almost always true, unless you have a false, then it's false. So the A and B is rarely true. You have to have 2 trues to make it true. The A or B is rarely false. You have to have 2 falses to make a false. The implies, the if-then statement. A implies B. Basically, this is like innocent until proven guilty. You assume it's all true. That's your start. Just assume these implies are all true. And the only way that you can prove that A did not imply B is if you get a true implies a false. That disproves the statement. Happened right there. True implies a false. False. That one didn't work. And you don't see this very often. So with just these three, let's do this bottom one. So first off, the truth table, hopefully this is the right number of rows, but I start with the last one that we have, the last statement, the C statement, and just alternate true, false, true, false, true, false, true, false. If I need to continue that pattern, if I need it, I can. The next one is a double repeat. So true, true, and then false, false. And true, true, then false, false. False. And then the one before that is a 4 times repeat. True, 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 true. False, 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 false. The next one after that would be an 8-time repeat. And if I had an 8-time repeat, I'd need to extend all these patterns more. So this gives you every possibility. So for example, what if there's only one false? It could be in the C, or in the B, or in the A. What if there's only one true? It could be in the A, or it could be in the B, or it could be in the C. What if they're all true? What if they're all false? Every possibility of these three statements is now here. Okay, so if we wanted to evaluate this, we'd want to work out, we've got A already, there it is. We don't have the opposite of this because we don't have this stuff yet. So I'd want to create a value for the B union C, or the B or C. And then I can look at the opposite, and then I can evaluate. So B or C. So we're looking at the B. Oh, this isn't going to let me do that. There we go. The B. Nope. Come on. Nope. Oh, come on. This thing is just so argumentative. There we go. The B or the C. Or. Now, or is almost always true. The only time it's not true is if you have a false, false, like right there. False, false makes false. We have another false, false. Yeah, right there. False, false makes false. The ands are almost always false. You need the true, true to make it true. Okay, so that's the first pattern. We just look at the B and the C. It's almost always true if it's the or, unless you have a false, false. The opposite of that, just switch them. True goes to false. False goes to true. True goes to false. False goes to true. That's all that is. It's just the opposite. And now we're doing the and. I can already start. The ands are almost always false. The only way they're not is a true, true makes a true. So we're looking at A. Oh, there we go. And this, we're looking for those. We're looking for a true, true. There's a true, 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 true. That one's a true. We've got to change that one. That's it. That's the only one that was a true, true. The only one that changed from all falses. And we've created a truth table. So these tables are useful to prove or disprove arguments. And then they'll just be like, fill these out as well. And you want to be able to fill them out. And up here, it really is for the ors, sorry, for the ands, a true, true gives you true. Other than that, they're all false. For the ors, a false, false gives you a false. Other than that, they're all true. And the implies They're all true unless you get a true gives you a false, then it's a false. So these assumptions, and then what do you look for to change, make these pretty easy to fill out. And of course, the opposite. Truth tables. De Morgan's laws. Inductive and deductive. If you are looking through like generalization and specifics, the last mayor was honest, specific. The current mayor is honest, specific. All mayors are honest, general. If you're trying to go from just specifics to a general, then you're using an inductive argument. You're trying to induce something. I forgot my purse every day last week. Now, those are a bunch of specifics, 7 specifics. It doesn't say I always forget my purse. That would be general. I forgot my purse today, specific. Therefore, I always forget my purse, general. This is an example of an inductive argument. So you really want to look for where is the general statement. All mammals have lungs, general. The dolphin is a mammal, specific. Implies, therefore, dolphin has lungs, specific. So there might be a specific in both the assumptions and the conclusion, or the premises and the conclusion. But wherever the general is, if the general is in the premises, then it's deductive. If the general is in the conclusion, then it's inductive. Really the way to tell is track the general, which one's the general statement. Like here, all firefighters know CPR, general. That's in the premise, it's deductive. All the rest is specific. Euler diagrams are interesting. If you have lipstick on your collar, then you are cheating on me. Premise. If you are cheating on me, then I will divorce you. So here we have the divorce circle, and also that is inside the not divorce, like everything includes divorce and stay together and everything else. Then cheating on me. If you're cheating, she will divorce you, or he will. And then if you have lipstick on your collar, then you're cheating on me. So lipstick. So every time there's lipstick on the collar, that means cheating is happening, just based on this premise. And every time there's cheating, that means divorce will happen. Premise, you do not have lipstick on your collar. Therefore, I will not divorce you. That's a specific. You do not have lipstick on your collar, so you're not in that circle. So you could be here, you could be here, you could be here. You're just not in there. So in other words, you might have done something else that's cheating, and she's going to divorce you, or he's going to divorce you. So conclusion, I will not divorce you. That one right there disproves the argument. As does that one. Both of those would be disproving. This one is the I will not divorce you, but that's not necessarily the case, because you might have cheated for some other reason, and you might have done something besides cheating that had a divorce happen. So both of these situations follow all the premises, but the conclusion is not met. So that disproves this argument. This argument is invalid using an Euler diagram. Item 16. There's still a lot more to do in this stuff. The voting theory. So did you all get a copy of the voting set measurement notes in the chat? Want to make sure you have them before. I have a class at 11:30, so I'm going to be leaving around 11:20. So I'm about done with this review. Wish I had more time. Clearly, we have more to review. Okay, preference schedule voting. First off, what's important about preference schedules is along the top are the votes. You can see that there are 3, 6, 9, 10 people involved in this vote. Plurality means just the most popular. So if I were looking at the plurality, A has 4 votes, 4 first place votes, they would win the plurality. 10 total, majority would have to have 6. 5 wouldn't be enough because 2 people would get 5 and that's not a winning situation. So you'd have to have 6 for a majority. A would win the plurality. No one would win the majority of this preference schedule. Instant runoff voting. You're going for majority, basically, with elimination. So you start off by just figuring out how many total votes there are. In this case is 121 votes. Divide that in half, 60.5. So 61 is the majority. Now we count. A has 25. B has 7. C has 41. D has 48. Does anyone have a majority? No. So the instant runoff voting is you throw out the loser, the one with the fewest votes. So B is gone. So C moves up. C and D both move up. A and D both move up. All of them move up. So everyone just kind of moves up to take up B's votes. And I have what's remaining, and I've rewritten it. It's one way to do it. Now the recount. D has still 48 votes. No one's in the majority. We throw out A. That changes the preference schedule. We then count up. 61, what was the majority? 61. C ends up winning. D was the plurality winner, but didn't win the voting method overall. That seems unfair. The board account. You take the 4th place, give it 1 point. 3rd place, 2 points. 2nd place, 3 points. 1st place, 4 points. The board account's the only one that uses all the different types of voting, 1st, 2nd, 3rd, and 4th, and calculates a score. So for Canada Day, there's 2 ways. You can go by columns. So these 10 people voted A 3rd place, worth 2 points. The 19 people, 4 points, etc. But you can also go by row. 4 points for all of these 19 people, plus 3 points for all of these 20 and 7 votes. 2 points for, and I'm looking for A, for these 10 votes, and 1 point for these 15 votes. A lot of people like to do it by rows instead of by columns. Doesn't matter, it all works out. When you're done, whoever has the most points wins the board accounts. The pairwise comparison method. Like if I wanted to work out A, C, I'm looking to see where is A above C. These 13 voters prefer A over C. These 10 voters prefer C over A. These 17 also prefer C over A. And these 14 prefer A over C. So there's a total of 27 Oh, and 27. These are equally preferred. Each gets a half a point. In every one-on-one battle, 1 point is assigned. So the AC, half a point each. You go through all of them, whoever gets the most points wins. In this case, a B, a C, a D, each person is going to have 3 battles. The most points they can have is 3 points. If anyone gets 3 points, they're called the Condorcet candidate. No one can get more than 3, and only one person can get the most of 3. And then going through the fairness criteria, interesting. And then there's also approval voting. How many people approved of B? 17 plus 17 plus 18. A has 56. Count how many each one has. Whoever has the most approval votes wins. All right, it's 11:22. I have to end this review. I hope this has been helpful. Go and watch these videos if you have time. They explain the stuff that's worked out. And then they also say, like, pause the video and work on the stuff that's not worked out, and then show you the answer so you can get a little more practice. All right, I appreciate it so much. Thank you very much, and good luck with your exam.